Okay, this video is for 8.7a, graphing cubic functions, and this will look a little pretty similar to, pretty similar to what we did yesterday. But it'll just focus on different types of cubic functions. So let's start with problems 1 and 2, and we'll do 11 and 12 as well. We'll do a couple problems each, and these decide if the equation or graph is cubic, quadratic, or linear. So 1 and 2. Now, problem number 1, this is a linear function. And if you take a look at the x value, or the x itself, it has an exponent of 1, and since it's not there, we assume it's 1. Anything with an exponent of 1 as the highest term exponent is a linear graph. In number 2, you can see that the highest term has an exponent of 2. The highest variable has an exponent of 2, so this is a quadratic graph. Let's just take a peek to number 3. The variable here has an exponent of 3, that's the highest term in the equation, so this one is a cubic graph. Alright, let's go down to 11 and 12. You can tell that 11 looks like a parabola. A parabola-shaped graph is a quadratic graph. And in number 12, graph is coming up. It bends and then continues to go up. That's a characteristic of our cubic functions. So this is a cubic graph. Alright, now let's look at number 16. We have two equations here. Y equals x cubed minus 5x and y equals negative x cubed plus 5x. So what we want to do is fill out the respective tables, graph the functions, and take a look at the differences. So they've given us the x values. All we have to do is plug those into the graph. Plug those into the equation, and once we do that, we will get the corresponding y values. So I like to start with the center, so I'm going to start with 0, and if we plug in 0 for x in the blue one, we will get 0 out. 0 cubed is 0, minus 5 times 0 is 0. Let's plug negative 1 in. If we plug negative 1 in, we will get 4. If we plug negative 2 in, we get 2. And if we plug negative 3 in, we get negative 12. Now going the other way, plugging 1 in, we get negative 4. Plugging 2 in, we get negative 2. And plugging 3 in, we get positive 12. Now let's do the same with the red. Starting with 0, we will also get 0. Now if we plug in negative 1, we get negative 4. If we plug in negative 2, we get negative 2. And if we plug in negative 3, we get positive 12. Now let's go the other way. Plug in 1, get positive 4. If we plug in 2, we get positive 2. And if we plug in 3, we get negative 12. Take a look at the y values from the blue graph and the red graph. It appears that they've flipped, so this almost looks like a reflection. Let's plot it and confirm that. Blue graph first starts at 0, 0, right there, goes to negative 1, 4, goes to negative 1, 4, and then negative 2, 2, and negative 3, negative 12. And then 1, negative 4, 2, negative 2, and 3, positive 12. Connect our dots, and our cubic function looks like this. Now let's plot the red one. 0, 0 also, but then negative 1, negative 4, negative 2, negative 2, negative 3, 12. Then 1, 4, 2, 2, and 3, negative 12. Connect the dots, and our cubic function, like we said, is the same but flipped. And so what we notice is this is a reflection.